video segment, I would like to discuss some of the capabilities and functionalities of the Feature Manager dialog box, which can be seen in the 3D Experience Release 2022x. Now, these are all inherited from the old Abacus program, or I shouldn't say the old Abacus program, which is actually the native FEA solver of the 3D experience at this point. Information about things like this can be found for the Abacus code on several video tutorials and internet resources. However, uh, very little is available for the 3D experience implementation and the interface of such a dialog box. Now, uh, the dialog box that I'm talking about can be obtained by going to the Feature Manager icon, and that can be done several different ways. One of them is you put the cursor on the blank screen on the interface and just right-click and select the Feature Manager from the menu, or you can go to the bottom of the page, bottom of the screen, where you can find the taskbar, and there is a stack up of icons here, and if you expand this thing, you see a Feature Manager there. Okay, when you activate the Feature Manager, you'll see a box like this. Okay, and in it, it shows you the restraints, the loads, the steps, and basically it shows you how information is propagated through different steps. This is something that is relatively well established, or reasonably well established, in the Abacus software itself, but since the interface is completely different and some of the functionalities are not available, what I'm showing you here is what happened in 3D Experience. I would like to do this thing in the context. You can see, for example, in this particular situation, clamp 1 is available through, is propagated through all three steps. Force 1 also through all three steps. Force 2 is through the last two steps. It's not active, it's not available in the first step. And finally, the last force, which is force 4, is only active in the last stage. Okay. Now, I want to do this in the context of an example where we can actually see how things work. For example, I'm looking at the bar, a cantilever clamped at this end. I didn't mention that here in the slide, but it's clamped at this end and it's subjected to two loads, an axial load in the x direction and a bending load in the y direction. Okay. Now, uh, the material this is assumed to be 1 inch by 1 inch, 10 inches long, standard properties of steel, and I'm going to be using what is called a sweep mesh to create a nice structured mesh like that. Now, the loads that are applied here in the x and y direction, 1,000 and 1,000 pound, will result in a von Mises stress distribution like that, and a bending deflection, or a deflection, which is shown on the right. The way I'm going to model this to explain what can be done in Feature Manager is by doing actually three steps. Step 1, apply load Fx. Step 2, applied load Fy. And step 3, applied load in the Z direction, which doesn't exist in our case, okay? But I will apply 1,000 pound in the Z direction. However, what I will do, I will come back to that Feature Manager dialog box and will delete or deactivate this last step to show you that uh, you will end up with what you expect. If you get rid of this by deleting or deactivating through working with the Feature Manager, you will end up what you expect to get. You might say, well, this is obvious. If you don't apply this or delete it, then why should it make a difference? I want to show you how this can be done through that feature manager dialog box. Okay, that's pretty much it. Okay, so let's go ahead and make our geometry very simple. So on the vertical plane, on the YZ plane, I will sketch a 1 inch by 1 inch square. Let's dimension this thing. This is 1 inch, and dimension this 1 inch. Exit and pad it by 10 inches. 10 inches. That's pretty much it. Let's create our material. So we go to tools, create a material. I'll call it uh, feature manager. Feature manager problem or video. Okay, and obviously the simulation domain is checked, which is good. Now it's going to be created here. Of course, it's right now it's blank. There's nothing in it. Right here, right click apply. Then we don't need this thing. We close it and we apply it to that part. And we go here, double click, and go to structures, abacus multiphysics, mechanical, elasticity, elastic, and over here I had 30 million, 1, 2, 3, 4, 5, 6, and 0.3. So 36 zeros and 0.3 for Poisson ratio. Okay, let me rename this thing so that I can find it if I need it later on. I'll call it feature manager video. Video. Okay, and we're gonna save. Okay, so we're gonna go to our structure model creation. We do the meshing. We use this icon standard, and we're going to change it to sweep. It's already on sweep, and those values that are used in this window is 0.25 inches for mesh size and 4 layers. 0.25 for mesh size, 0.25 inches for mesh size and 4 layers. And I'm using linear element order. It really doesn't matter. It's just for explanation purposes. Okay, so it's already meshed. If you want to see it, I thought it was 0.25 inches, correct? That not four layers. This I don't know. Let's make it 10 layers. See whether you get this. That's maybe 20 layers. Okay, that's more like it. For some reason, I thought this was 4. Number of layers is 4, but I suppose I did this thing differently. Actually, this seems to be a little bit there's more than yeah. So it could be that this is let's try 40. Yeah, okay. I don't know why I said 4 layers. That's 40. Okay, good. Now, the model is made, and let's go ahead and create our scenario. So structure model scenario creation. And we're going to use our finite element model that was created. Okay. So we are going to apply 3 static steps. So the first one, now notice that here, uh, this includes any geometric nonlinearities, deformations, or log used as the appropriate strain measure. Now, this is a very simple problem, so whether I use this or not, it makes absolutely no difference. Let me uncheck it. Let me uncheck it. So I'm going to do 3 linear steps, and then I come back and show you what happens if you actually uh, did this. All right, good. We're going to clamp the other end. So this is clamping this other end. And that's going to be clamping all 3 steps that I will create. Okay. Then we're going to apply the load. The load is a force in the direction x, which is 1000. Now what happens here, you can see that similar to what is done in abacus, the way it's done in abacus, these restraints are outside. It's listed here outside of the step, probably similar to what is done, what is called initial step there. But anyway, but when you go to the first static step, that restraint is there, and the force 1, which is 1,000 pound x direction, is also here. And of course, it's also there. You see that. So clamp, force 1, force 1. Now we're going to apply our second step. So we go to procedure, step 2. Once again, I'm going to deactivate this nonlinear geometry effect. Okay. And then load on that face, force in the direction y, 1,000 pounds. Okay. That's the problem that I want to solve. In other words, that is the thing that I want to do, and I expect to get these results. But what I'm going to do is I'm going to create a third step. Okay, so a third step. By the way, notice that load 1 and force 1 and force 2 are up here, but in static step 2, force 1 and force 2 are also present. It's kind of propagated through this. Finally, I'm going to create another step number 3. Now this load I do not want, but I'll do it anyways. So uncheck the geometry, nonlinear geometric effect, and then we go to load, and then you apply a force on that face in the direction z, 1,000 pounds. There we are. Okay. So notice that force 1, 2, 3 are up here, and force 1 is present in step 1, force 1 and force 2 in step 2, and force 1, 2, and 3 are all in present in the 3 steps uh, uh, in the step 3. Okay, good. But clamp 1 is present in all of them. All right, now feature manager. So let's see. You can either do right click, feature manager, it appears here, or as I showed you in the slide, you can go down here and go to feature manager. Either way. So notice what happens here. You have step 1, step 2, and 3. You have clamp 1, and clamp 1 is present in all of these. You can see that. Okay. Force 1 is present in all 3. All 3, correct. Okay. Force 2 was not in step 1, but it is present in step 2 and 3. And finally, force 3 is acting in step 3. Now, that is not what I want. I don't want this. But let me go ahead and run it with this information. So we go to simulate. I'm not going to do data check and scenario check, so I'm just going to run it because this is a simple problem. You can see that it's unlikely that anything will go wrong. Now, the results that I'm going to get are not going to be the same thing that I showed you in the slides, because in those in the von Mises stress and displacement there was no force in the z direction. Okay, after I show you this, I'm going to that dialog box, feature manager dialog box, and deactivate that third force. Okay, in other words, force 3 I'm going to deactivate. Run it, you'll see that you get what you expect, and come back. Instead of deactivating, I'm going to completely delete it. Okay, and you see that gives you the same effect. Okay, good. This is finished. Okay, so it's not surprising that the von Mises stress, it's not surprising that the von Mises stress does not look like this, and the numbers are not the same. Okay, and I just noticed here something. Yeah, that's good. All right, and so what I'm going to do is I'm going to go uh, to that feature manager. Let me close this feature manager. Except that this does not show you. This does not show you this the stuff that I need to access. So you go to scenario. You go to scenario. That's why in the transparency, I'm saying while in the scenario, right click. Okay, so right click feature manager, and now you can see all the steps are present and the forces are right here. So first thing I'm going to do, I'm going to go to this force 3 and deactivate it. Right click, deactivate. But I want to show you something here. See that? Already these 3 forces are up there. When I selected this, see that when I selected this, that got uh, highlighted. Now I'm going to deactivate that. You can do it from here, or you can do it from here. But I will try to do it with this dialog box. So I want to show you the similarity of what you have in the Abacus CAE software and 3D Experience. It's not similarity, it's the same thing. Right click, deactivate. Notice that when I do that, it got deactivated, and notice that there is a deactivation mark right there. Okay, so we no longer have a force in the Z direction. Let's run it. And assuming it's the same mesh, I think it's the same mesh, I should be getting the same results. Same results as what you see here. There may be some minor differences because of the mesh. I thought they were the same, but the advantage of deactivating as opposed to completely deleting actually removes this line force 3 from the tree. So if you want to, in fact, you want to come back and do it, then you have to add the force again. Deactivating just takes it out of the loop. Notice that when I deactivate, by the way, from step 3, force 3 kind of goes away. You can see that. Good. So right there, you can see that. This is no vertical force present, 5.82 e to the 4, which matches exactly what I have here. And if you look at the displacement in step 3, displacement, you get 0.133, and that's 0.133. Now, also notice that this was step 3. If I go to step 2, I get exactly the same thing as in step 3, because basically I don't do anything in step 3. Same thing. And if you look at this is step 2, and von Mises is, again, same thing. Now, obviously, if you go to step 1, it's just axially loaded. Okay? All right, now, I want to go back. I want to go back to scenario. Okay. I want to go back to scenario, and feature manager right there. And this time, you see, I can always bring it back. Right click, activate. It comes back. The advantage is that I did not delete it. If I needed that account, but you can also go there and right click and delete, which can also be done from here. Right click and delete. But I want to show you what happens in the feature manager dialog box. Right click, delete, gone. So if you ever need that, you have to come back and apply the force in the appropriate step. Okay. Now, if I run this thing, I will get exactly the same information that I got by deactivating, and that basically takes care of the video segment, except for that business of linearity or non-linearity, which I can come back and do. So let's run it. Almost done. Okay, so let's get rid of this. This is step one. If you go to step two, you get exactly the information that I have here. Okay, so, and if you go to step three, again, same information because there's nothing that is done in step three. Now, you might say, what about that business of linear, including the effect of nonlinear geometry? Well, if you go back to step one, if you go back to step one and go there and include that, remember I took that away from step one, two, and three. But if you do it in step one, say okay, and if you check your step two, which is right here, you see that that's checked also, right there. And step three, that's also checked. I didn't do that, but as soon as I check the include geometric nonlinearity in step one, automatically it put it in all the other ones. Okay, and you can deactivate anyone. Believe me, if I run this thing, I'll get exactly what I got when I did the linear case. Okay, hopefully this sheds some light on this business of feature manager dialog box, because this is the counterpart of that is available in the Abacus CAE software when you create a job. Okay, when you create a job, it I'm not sure a job or a step. It shows you what is propagated through the analysis. Okay, so that same thing is here. No wonder, because what is buried here is actually the Abacus CAE. Yeah, and if you know Abacus CAE, it's really, it's almost identical to in a 3D experience. This is not called Abacus CAE. It's the default. It's the default or native FEA solver in 3D experience. As simple as that. Good luck.